Ali. So it's a great honor for us. Thank you for coming here. It's a great honor to have Akito van Troyer here. I had the opportunity to meet him last year in Boston, more specifically in MIT. He works at MIT. He did his PhD there. And there's a very interesting group on, what's the name of the group?
It's called the Opera of the Future.
Opera of the Future research group in the Media Lab. The Media Lab is a very crazy place with lots of engineers, artists, scientists get together to build strange things and very nice things and very creative things. And his group does that with music within that very high-tech environment. So he's a researcher there, but he's also a professor of new technologies.
Yeah, electronic production and design is the appropriate term.
Yeah, electronic production and design at the Berklee College of Music. Berklee is very famous for popular music education in the United States and worldwide, and he takes care of that electronic music production there. So thank you very much.
Yeah. Hello, everyone. My name is Akito van Troyer, and thank you for having me over here at the very last minute. And I'm really great that this worked out. And I'm really happy to be here to present my work. I'm calling it Music, Wonder, and Machine. Kind of represents type of research I've been doing, and then the theme that seems to always come out through the projects I've been working on. Before I get deep dive into my work, I wanted to kind of introduce myself again. I'm an assistant professor at the Berklee College of Music, Electronic Production and Design. It's a department formerly called Music Synthesis. It's where students learn to use synthesizer for the most part. So I teach classes about sound design, for example. I teach classes about computer science and music. Those are kind of like the two sides of classes I've been teaching. At the same time, at the Berklee, I'm also at the MIT Media Lab. This is the building right across the river from Berklee. So it's very close to each other. So I just bike in between the two all the time. It's really nice. But this is where, like Fabio said, lots of interdisciplinary research is going on. We put designers, engineers, scientists, artists in one place, and let's come up with a crazy idea and do a research on. And this is the building that takes place. Yeah. So here are some of the images I'm showing to you right now that I'm going to talk about today. It represents some of the works I do. And most of them are about music and new technology that enable people to musically wander their world, basically. I create new explorative music systems. This talk is about music making as well. To this extent, my work focuses on extending expression and learning through innovations in music. And I am drawn to this research area because I want to impact the future of human expression and experience to enrich people's lives. So a little more about my background. I make new musical instruments, and I wanted to show you, this is the primary reason I'm actually here. I'm on my way to a conference named NIME, New Interface for Musical Expression, that's currently taking place at Porto Alegre. And I'm flying right after this, but in that spirit, I do make a musical instrument, and I wanted to show you one example that's called the drum top. It's a tabletop musical instrument. So yeah, that's just one example of instrument I made. I will talk more about drum top later on, but I wanted to move on with introducing my background. Another area I work on is an interactive music system for performance specifically. This one is called the LOLC, stands for Laptop Orchestra Live Coding. This is an interface that audience member sees through the projection, where you can see what the performers are typing in on their laptop. It comes out as a chat message, so that audience member can kind of see what kind of thoughts are going through the musician. And this is how the performance looks like. So these blobs represent the performer, and each blob connection shows what kind of musical patterns are being shared among the musician. And here you see the chat message. They're basically communicating what should be coming next and so forth. And so down there you can actually see the laptop performers communicating. Yeah, so it's 10 minutes performance, but I'm cutting it short, 30 seconds. But another kind of my background is in machine listening. How do you train computers to listen like human being? And I had the pleasure to work with a robot named Shimon. It's a marimba robot that basically tries to play with a human musician. And I got to program this robot to detect a beat of what the human musician is playing on the marimba, and then nods his head based on the what's going on with the music. And this is the performance. So yeah, computer audition is some very big topic in the music technology research domain. And when I was talking to Fabio, there's a research group doing work related to this as well. So lots of digital signal processing and hard math goes into playing music with robots and things like that. Yeah. So I'm gonna next introduce you to two projects that really, or three projects actually, really inspired to got me to think about music wandering and machine type of things. And these three projects were done at the MIT Media Lab in the research group called the Opera of the Future. And the first project is called The Death and the Powers. As the name suggests, the Opera of the Future, the research group works on implementing new opera. And Death and the Powers is a robotic opera. Everything you see on stage, except 4 actors, are all robots, including the stage set. The story is important for opera, typically, right? It's about this rich, powerful man who wants to die, but he wants to leave everything about himself in this world. So he downloads himself into what we call the system or the furniture in the environment, and he dies. So in the show, literally, first scene, what happens is the main character dies, and he never comes back on stage again. So what we do behind the scene is we hook him up with a bunch of sensors to measure his singing expression, basically. Of course, we take measurements on the voice itself. We take measurements on hand motions, how the leg is moving, the chest expansion, and so forth. And we try to extract the emotional quality of what the singer is doing and translate that information to robots, lights, robot movements, and sounds, basically. So I'm going to show you a quick excerpt about the opera, so you know more of the context before I move on.
I have billions of clocks, and I can still sign tracks. I came from light, and I will return to
So you've seen the opera, so you don't have to actually go to see the actual show now. One thing I forgot to mention from the previous slide is why even do this kind of performance to begin with. And the research question we were really giving out was this thing called the disembodied performance. How do you represent a character without that person being present on stage? That was really the research question we were throwing out for this performance. And then that's why we hooked up the main character with a bunch of sensors and then have his telepresence onto the stage through the displays and the robot movements and so forth. Yeah, so I was actually primarily working as a chief robot operator. That was my title for the opera. You know, it's an opera work, so obviously 100 people worked on this or more. And my role was to make sure all the robots runs. And I want to show you some of the robot components of the opera. One is the chandelier that opens up and closes during the show. It's also actually a giant musical instrument. The performer comes up sometimes to strum like a harp to play music with. In the video, you probably saw that giant walls were moving. They were also equipped with a low resolution LED display to display the emotional quality of the main character and so forth. They're very, fully autonomous, meaning they know exactly where they are on stage because we do indoor location tracking on them. And we have like algorithms for, collision detection and things like that. So they don't, hit each other. They might hit people, but they don't hit each other. Yeah. for example, yeah. And then we have a bunch of tiny robots. They're like a Greek chorus. We replaced it, with the humans, with triangle robots. They're semi-autonomous, meaning the articulation and lighting was automated, but the driving was done by puppeteer. And we used the Xbox controller during the show, looking down from the wings of the theater to know, where to move the robots and things like that. So it's very fun, actually. Yeah, you're kind of like performing without actually being on stage, right? Through the robot. Yeah. So that was a very inspirational project. For me, learning how robots can be part of the theater performance, and for that to happen, the huge thing I learned was the network. How do you make sure all the computers talk to each other during 1.5 hour of show? Basically, we counted about 50 computers running simultaneously during this performance, and it was a pretty intense setup for what I remember. So I'm moving on to another project called the Sleep No More, extending Sleep No More. Anybody heard Sleep No More before? Yes? Awesome. At least one person knows. Yes, I'm glad. So let me introduce you to Sleep No More a little bit before I dive into this project. So Sleep No More is a site-specific theater performance currently taking place in New York, West Chelsea. They turn a building that's 5 floors high with 100 rooms into a theater space. So it's not like a traditional theater performance at all, where the stage and the audience is separated. It's not like that at all. You as an audience, you wear a mask, like you see on the picture over here, and you basically wander around the space. You can decide to, before I say that, there are about 30 actors in the space simultaneously performing all over the space. So you can decide to follow characters, or you can just choose to just wander around the space, treat it as an art installation if you want, or maybe you can just sit around and have a drink. And it's very open-ended what you can do in this performance space. It's about 3 hours long that you get to experience this. There's definite start and end to the performance, but every time you go, you're gonna experience something different because there's so many things happening always. I will show you another image of Sleep No More from different scene. It's very abstract. Did you see the show actually?
No.
Okay.
I couldn't get the tickets.
Yeah, it's very, very popular. So I would strongly suggest if you go to New York, go see this. It's kind of expensive, but it's worth it. Yeah, you will not see anything like this anywhere else, basically.
How expensive is expensive?
It depends on the night. Like weekends are pretty expensive, like 200. Yeah, but I think weekdays are pretty cheaper. Like goes down to 100. 150 maybe, yeah, 100 to 150, I'll say, yeah. But it's definitely worth it. Yeah, it's spend an evening at the theater area is like a nice way to spend time in New York, I would say, sure. Yeah. the performance itself is very abstract performance. The actors don't talk at all. It's very like a dance-oriented performance. But the story itself is based on Macbeth and a Hitchcock movie called Rebecca. I don't know how many of you have seen that before, but it's a mashup of two stories in a performance, basically. Yeah, so I'm gonna give you a little more context with a video, actually, what Sleep No More experience might be. So yeah, a little kind of spooky, but it's also a really, really interesting performance. But one of the problem with Sleep No More is that you actually need to go to New York to be able to see this, right? So Punch Drunk, who produced this theater performance, knew the exact same problem, and they approached us and asked us, can we extend the experience beyond the actual physical performance space? So in collaboration with Punch Drunk, what we did was to build an online component of a performance system, basically connecting the online audience member to on-site audience member, pair them up, and then wander around the space together. Basically, that was the project we came up with. And the next video is basically shows you the concept of this entire project. Hello?
Any trail?
So yeah, hopefully some of the concept came through the video, but obviously we have to make an online component of the performance, and this is the browser interface we kind of came up with. Anybody played text adventure games from 80s before, like Zork, for example? Does it ring a bell? Yes. So the cool thing about text adventure game is you can type in anything, right? And it will respond to you with something. that metaphor fit really well with Sleep No More, where physically you can go anywhere, explore around. You cannot talk, but pretty much free to do what you want to do. So we took that metaphor and then built the interface based on text adventure game. If you hit the right keyword, it will give you multimedia experience, like actual video feed from the performance space, or some nice imagery that pops out in the background. And of course, we have an immersive audio system that's coming out from the speaker set as well. So that's the remote component. We also had to develop a system for the on-site audience member to be able to communicate with a remote audience member. So we augmented objects that's in the Sleep No More performance space. So we call them portal objects. So here I'm showing a typewriter that types by itself, but it's actually being triggered by the remote audience member to try to communicate about, hey, you should go to that, or combination for that suitcase is 539 or something like that. Whatever, it directly types on that paper, for example. It's really, if you don't know the context, it's very spooky actually. Yeah, because it's just typing by itself. Yeah. Another portal object example is a bookshelf. We installed a machine in there that drops the book automatically when someone passes by. And then inside the book, there's a note that gives you clues, basically where to go and things like that. So, as much as this is a theater performance and experience, it also has that, game component to it, right? Which I think it makes it really, really interesting in terms of like exploring the performance space. We also augmented the mask of the audience member. That's actually the majority of work. What I did for this project is to integrate sensors, for example, to measure where this person is in the performance space. So indoor location tracking system built into the mask. We also had a biometric sensor to measure, for example, heart rate, how much sweat this person is having right now, to kind of like quantify the emotional states of that person. We also had an environment sensor, like the microphone or light sensor, to try to determine where exactly this person is right now, and then what kind of experience they might be having. We also had a bone conduction headset right there, so a remote audience member could directly talk through the the person without interfering with the actual physical space sounds that's coming from the actual physical space. Yeah, so that's a whole wearable system we worked on. So of course we needed to connect the remote audience member and the on-site audience member. We needed a control room as well. We monitored the conversation between the two. So we took up an entire room. This is only a portion of it, but we have lots of security cameras and computers in that room to make sure the performance is going smoothly through that control room, basically. So yeah, I won't talk about this too much, but this is the entire computer architecture we came up with for this performance to happen. For example, there's a mask, portal objects, and we have a server system that takes those information and then how it connected to the remote audience member and so forth. Yeah, so this again was a large project. Lots of people worked on it, and it was a trial project as well. So we only run this project for a week and then call it done. But we learned a lot from this experience, and this kind of leads to the next project. It's called a Repertory Linux. So experience from Sleep No More, we kind of wanted to make it happen in the same way we did with Sleep No More in terms of music context. So in collaboration with a Guardian it's a UK news agency, we basically came up with a system where an audience member can suggest a pianist what they can want to hear from that pianist. And in real time, the display over there coming from the audience member, pianist takes that and then translates it into an improvisational piano session, basically. Really quickly, again, I'm just going to show you the entire computer architecture to make this happen. You had a bunch of website visitors suggesting, hey, pianist, can you play that type of thing? And performer gets that, and then we do a web streaming at the same time. So what is it? It's not just one-way communication, but two-way. There's a closed-loop communication happening between the audience member and the performer. Yeah. So this is more of the interface for the audience member. They could just, it's a website again, right? So you could use the mouse basically to kind of like steer over which artist you want to hear the most. In this case, it's a bunch of famous composers from the past, like Beethoven, Bach, Brahms, and so forth. So if you wanted to hear Brahms, you just go to Brahms and then make that bubble bigger so the pianist can see it, and then he will start to improvise more in the fashion of Brahms, for example. So let me play the video first and then tell you more about it. I think I will stop it right there. Yeah, while this is going on, I'm just going to refer back to the previous video. 90% of work is actually done by the pianist. And we just developed the technology for that particular pianist. Finding that pianist was very hard because he would literally be able to like improvise any kind of style, you know. So let's build a technology for him, you know, was basically the idea of this project. So we continue to experiment with this project. We did a second round of Repertory Remix. This time, not only the website visitors, but actual audience in the physical space as well. They could join in to suggest what kind of style they wanted to hear using their mobile phone in this case. And we made it much more simpler. Either play in the Beethoven style or the pianist style. And then if it's red, it's in the pianist style. And if it's blue, it's more in the Beethoven style, basically. That's kind of as simple as it gets in terms of interaction. And again, we did a performance. Looks something like this. The audio quality is not that great, but hopefully you get some idea. The pianist also has a display just like the before. You just can't see it from this video. Yeah, so the concert hall is not on fire, just to make sure. It's just an overlay. But the cool thing about doing network-based music performance is that you can get a bunch of data out of it, and you can actually do a pulse analysis how the performance went. So this is just to show you that you can actually do this and also, you know, publish a paper based on this kind of idea. So those are the three projects kind of like, you know, inspire me to push the direction of, you know, inviting people to be part of the music network and so forth. And this is basically my PhD work. I call it the score instruments. Let me talk about this more in detail. Score instruments basically are interactive music systems that merge both instrument and score into a unified interface. Instrument and score, those are two essential for making music happen, right? And can we make that integral part as a single entity, basically? That was the idea behind the research. The unification of an instrument and score is achieved through music visualization, animations, and automations. And hopefully through some of the works I've already shown you, you start to see that pattern. Lots of visualization is going on, for example. And the focus of such systems are open-ended music making. Yeah, so you don't have to necessarily have be an expert in playing music. You don't have to have any musical knowledge. You just, interface will invite you to do something musical with it, basically. And these score instruments are catered towards specific audience, and I call them the musical wanderers. There are individuals who develop curiosity towards music in everyday installation and concert context. And there are people who focus on interpreting and exploring music rather than on technically correct realization. Yeah, so, obvious audience member could be children, for example, or older adults, who's, don't really care about being technical, but, just want to have fun, yeah, and so forth. So if I want to make this into more formal, kind of like a descriptive relationship between the score instrument and musical wonder, this diagram is something I could use to explain that. So musical wonders can be a composer and performer when they're giving instruction to that score instrument. Score instruments will then, respond with a multimodal feedback, like of course sound, but maybe visual, maybe tactile feedback. And then, then when the response comes back to the musical wonders, they're a listener. So in between being a composer, performer, and the listener, they're doing the evaluation constant. And then this closed loop circuit goes on and on in the process of music making, basically. So with this in mind, I'm going to show you two projects that I mostly worked on for my PhD project. And first one is called the City Symphony project. So City Symphony project is in itself, it's again a large project, like 10,000 people worldwide participated in. As the name suggests, we do this project in a city scale, and we've been deploying this in different cities. For example, we did it in the city of Toronto, Edinburgh in UK, Perth in Australia, Lucerne in Switzerland, Detroit, and then the newest one has been in Philadelphia in the USA. Yeah, but my primary involvement in this project was about facilitating online massive musical collaboration. So how do you, ask people within a city to contribute musical material to us so that we can integrate their contribution into the final performance we're going to be playing together. So for that to happen, I basically made an online system where people can upload sounds. It's basically a mobile app that you can take out, go out in the city, hit record button. It will geotag those recordings, and when you upload it, it will auto-populate onto Google Maps. So people can go onto the website and then listen to sounds without actually going to that physical location. So it's a platform where people can kind of like discuss the sound within the city, basically. And I have a video again that explains the concept a little more better. So I'm going to show you that. It's a video from a city of Miami when we did this project with them. And then they're branding the sound theory, which is the project I'm calling it, as Project 305. Yeah, so here's the video.
Project 305 is a community-sourced symphony inviting you to tell your story of living in Miami from your perspective through video and sound submissions. Welcome to Project 305's community of collaborators. The easiest way to share your Miami is by submitting via the Project 305 app. If you're familiar with common social media photo apps, it functions similarly and intuitively. Search the App Store for Project 305. The app is free. Download the app in your preferred language. There are versions in English, Spanish, and Haitian Creole. If it's your first time, create a user account or authenticate with Facebook. On the home screen, you can choose to upload an existing sound or video from your phone or record a new sound or video. Point your phone at your subject and share your perspective of our city. Anything you find interesting from your daily experience. Hit the record button. When you are finished recording, complete the data fields on the following page. After all the fields are completed, hit upload to submit your recording.
So hopefully this video puts the context a little more better. It was a project to get lots of sounds from people who's within that city again, right? Through this app, we get a bunch of sound data. So what do we do with them? We didn't want it to stop just by collecting, right? We wanted to use that sound in the new context. So what we do with these sound data is to do an analysis on it. We do a feature extraction. I won't talk about it too much in detail, but sound has a property, right? Like what's the pitch, what is the amplitude, what's the timbre quality, and so forth, right? So you automatically extract them and make a new database out of it. And through that database, what we create is visual sound objects that can run off of websites, basically. So why do we do this? It's because we're going to provide the people within that city to start composing a piece of music with all the uploaded sounds by other people, basically. So we're calling it the score-making web application. I've made a bunch of them, but I briefly talk about like 3 of them so far. So the first one is called the Cauldron that I made for the city of Edinburgh, where it's known for witch culture. And the Cauldron is a very, monumental thing for witch, right? Where you mix to make magic happen, basically, kind of thing. So we took the same kind of metaphor where you can steer to make music with. And this is how the interaction looks like. So those tiny dots are all sounds. Ingredients eventually disappears over time, as expected, because it's a cauldron, everything, it's a melting pot, right? So you have to keep adding new ingredients to make music with. So the next one I made is called a water app. It's made for the city of Lucerne in Switzerland, where it's known for a water quality. There's like more fountains than any other city in the world. For example, a bunch of rivers, and it always rains. So like water sound is very prominent in that city. So based on that idea, I came up with this score making web app where people connect different cells to, kind of create like a water soundscape type of sound. So the final one I'm going to show you is called the Constellation. This is a little bit more of a generic web app we've been using for different cities. But the idea is, again, each dots you see on screen is a sound uploaded by some users from a particular city. And what you do in this interface is to basically click and drag around. And then the interface will automatically mash up or remix all those tiny sounds together in real time. So yeah, first stage is kind of like exploring. this one was kind of done with orchestral sound, but in the real world context, we've been using it with soundscape sounds that's been uploaded by people. And again, the second part was like drawing, right? That's where the actual score making comes in. So you don't really need, music training to be able to do it. As long as you can, use your mouse, you should be able to compose a piece of music. And finally, what we do is to encourage them to upload their music score to us. And we will definitely listen to everything and then incorporate it into the final piece of music that will be performed in orchestral, basically. Yeah, that's the context of a City Symphony project I worked on. And I'm moving on to a next project, which is a physical manifestation of the score instruments. And it's called MMRT. It stands for material, magnet, rhythm, and timbre. If you remember the drum top project, it's kind of like an extension of that project. It's a tabletop musical instrument equipped with electromagnets. What this means is anything magnetic you introduce on top of this musical instrument will become your musical material, basically. So this is how it works. So I'm going to talk a little bit about what can you do with an MMRT. And the display is actually quite an important part of it for people to understand what's going on with this musical instrument. And there are 4 modes mainly: percussion, melody, something I'm calling it the grain mode, and finally the microphone mode. So the percussion, just like the drum top we saw earlier, there's some actuators that's popping out from the bottom, and anything you put on top of it will become your percussion, source of percussion sounds, right? Yeah. I think the third one is actually not working, unfortunately. And so drum top was only capable of doing percussive sound stuff, but this MMRT can also do melodic pattern, as you heard earlier. Yeah, and for these guys, it works really well with a kind of like a resonating cup type of thing. And you see there's a magnet, right? So magnet is essential in vibrating the whole structure to be able to produce the sound. So in a way, you're making your own speakers on the fly, basically. Yeah. And the next one, I'm calling it the grain mode. The name comes from, I don't know if you're familiar with a synthesis technique called granular synthesis. And this is basically doing a physical version of a granular synthesis. Yeah, only MMRT is capable of doing this because it vibrates the magnet really, really fast. And, if you ask a human musician, it might be very, very difficult to, play this fast to be able to do something like this. And the final mode here is the microphone input mode. But microphone input mode is mainly used in a collaboration with other musicians. So I'm going to show you one of the performances I did in collaboration with a cello player. It's actually my former advisor doing performance together. And this is how I'm directly feeding the microphone input from the cello into MMRT. So yeah, this kind of adds another layer for the cello player here. Like, you have the cello sound, but on top of that, you have crazy timbres going on in conjunction with his improvisation and so forth. So I want to end the MMRT with the solo performance I did at the Gotham musical instrument competition. It's probably the only one in the world where you get to showcase your musical instrument and earn a prize for it. And MMRT was chosen as the most unusual musical instrument for the competition. And this is the performance I did for that particular event. For the interest of time, I'm gonna keep moving on to the next project. This project is gonna be one of the newest projects I've been working on, and the reason why I'm here again, I'm going to present this work at the 9. But again, it comes from this score instrument kind of idea of designing interfaces that's visually more attractive to play with. So I'm calling it a rendering 9 using AI technology. And maybe 1 or 2 years ago, it was very hyped thing that image to image transfer technique using AI was pretty commonplace. Like translating, Monet's painting into realistic photograph, or take an existing photograph and turn it into kind of a Van Gogh style painting, for example. It uses the same technology, but instead of generating artwork and so forth, I'm generating new musical interface. So let me give you a little more context. So music and media interfaces are pervasive and recognized by their unique aesthetics, often composed of knobs, sliders, keyboards, pads, displays, and things like that, right? It's pretty ubiquitous at this point. You find it all over the place, right? And the design of musical interface is guided by ergonomics, aesthetic, and musical rules, but also by, tradition, like music theory, for example, and the creativity of the industrial designers who, make this prototype and so forth. So what I did was to basically collect lots and lots of online, photos of different musical interfaces, right? Go to Amazon, Sweetwater, I don't know what's common in Brazil to buy new musical instruments and things like that, but you probably know. Great thing about commercial musical interface is that all the photos are taken in a controlled environment, so it's easy to manipulate them when you collect it and make it into a database. I've also collected other types of images. For example, tile patterns we're going to be using to transfer interface components onto it. I also have a bunch of abstract paintings that, again, we're going to do the same thing, take the knobs and things like that and put it into the paintings, basically, right? And the center one, it's kind of like a proof of concept idea, taking traces of a musical interface and then automatically creating new musical instrument based on that interface, sorry. Yeah, so we trained 3 models using something called the generative adversarial network. It's really hard to say that word. Shorthand for GAN is more known as to generate new musical interface design inspired by new interface images, basically. So GAN is typically it's a neural networks, or maybe everybody have heard of deep learning or something like that, right? Before it's a technology based on that, and it comes in 2 parts. One is the generator, and another is the discriminator. So they're fighting with each other to basically come up with a realistic image. So this, the GAN technique is mostly using the image domain, not so much for music, but slowly people are doing it into music domain as well. So if you're interested in like AI and music, GAN is something I would definitely recommend you taking a look. Yeah, so one of the library I use for this is called the Pix2Pix. So you can do this also by yourself. It's a very, very popular platform, or the library people use these days. So in Pix2Pix, what you do is to create a pair of images. One is called the label. So this is, let's say that is the label, and then on the other side is the real image, right? So you create these paired images and then create a database out of it. So once you have the database, you create a label that does not have a pair, but the library will automatically generate the pair for you based on all the database that you created with. So that means, what is it? You see the traces all the way bottom of the bag, right? You could, give those kind of paired images, but once the library has enough images or the database, you can hand draw something. It will automatically generate bags for you, whatever shape you make, for example. Another library I use is called CycleGAN. Project applies image-to-image translation without requiring paired images. So that's a huge difference from the before. You just provide a bunch of, for example, Monet's painting as one image set and realistic photo as another set, and then you can, translate between the two, basically. I think zero courses makes the most sense in terms of explaining. If you have a bunch of zero images and horse images, you can translate zero into horse or horse into zero. Right? It's really fun to make the videos and stuff like that based on this idea. So these are the 2 libraries I use in making this project happen. It's very explorative, I would say. So the first one, Pix2Pix, right? I fit in the outline, and then that's the bottom image is the original target, original image, right? So can my system, the database and the AI system, generate closer to what is targeted? And the result is pretty close, right? The color is off, but most media interfaces are black or white, right? Red is actually unusual. So it depends on how you interpret this, but I would say this is pretty good in terms of what it has generated. So 2 more examples here. You have the traces and then original target all the way there, and the center image is the actual generated result, right? So again, I think it's pretty close in terms of how it's trying to populate all the interface components and so forth. But this is like kind of like a proof of concept. How close is it getting and so forth? What's really interesting to do is to do hand drawing, right? So now I have this traces of database. I can just hand draw on something and then auto populate with the components. So first result, it's very cartoonish and things like that. But if you ask the professional, drawer or something like that, that person would do better than I did. Yeah, for sure. Yeah. So more examples. Yeah. So you can make like wacky, drawings of your new musical interface and then auto populate all the, components into it automatically, right? So this, I don't know, if you're interested in designing musical interface, it could be a pretty powerful, library to be able to do something like this, in my opinion. So the next is we use the tile pattern, right? So we wanted to take all the interface components, knobs, sliders, and things like that, and then put it into tile pattern, and then see what happens, right? So that's on the right side is a generated image based on the tile pattern on the left side. Sorry, yeah, okay, good. Yeah, so more examples here. I would say like tile didn't work out so well. I don't know, because maybe our database was limited, or maybe the tile patterns were too generic and didn't have like specific styles or something like that. It wasn't as compelling as I was hoping to. But when we had the abstract 2D paintings, it worked out much, much better. So here, again, the generated image is on that side, and this is the original image. And you can see that it keeps the original artwork, but populates with all those knobs and things like that, right? So you could kind of like, it's hard to point out, but in the center, there's something looking like a display, for example. There's a bunch of plugs into it, knobs and things like that. And this gets really, really fun. Like you can just like do this over and over. And you can recognize the original artwork and how it's translated into the actual musical interface based on that, right? Yeah, so more to kind of see. So I would say like the ones that tend to work well is artwork that has a really defined shapes into it. Like if it, for example, Bridget Riley, it's like very, very, line oriented, right? So in that case, I don't think it's doing that well. But for example, Eric Botchholz here, I think that interface looks kind of interesting. I want to touch and start doing something with, for example. And there's a bunch of examples again like this. Some of them look like a mixer interface, and while other could be like a modular synthesizer kind of interface, right? And I use the Mondrian here as kind of like a metaphor, and those are kind of like famous painting. And then what if we just like use that as a template for new kind of like a musical interface? Yeah. So, but again, I'm using the cycle GAN, right? If you can like apply interface into the artwork, I should be able to do the opposite, right? Take the interface and then make it into an artwork, right? So that's what I did. So this is kind of like a pretty vintage, like Berklee like interface, pretty famous also, right? And then if you turn it into abstract artwork, it would become like that, right? And take a mixer. Oh, this is a MIDI controller, sorry. And then put it into, I don't know, the systems. It came out with something like a hand. I don't know how it's happening, but it's happening. Yeah, it's kind of interesting what it becomes. Yeah. So real tape recorder, turn it into something, a face that's crying or something like that. Yeah, so I don't know. I think there's huge potential here in like kind of like exploring new kind of interface or artworks and things like that. And I wanted to also make sure to connect this to the scoring instrument and musical wonders idea. Making interface like this may attract them to, not think too much about technical stuff, but oh, what is this? Super interesting. Just try to touch, play around. Yeah. So I would say this is basically all the projects I've been working on so far. And since last year, I graduated last year, basically, and then I became professor at the Berklee College of Music, which means I've been teaching a lot, basically. And all these work I have done in the past are leading me towards providing a platform for learning for people, especially musical novices. So this is one of the live I've done at the Brains On podcast live kind of thing. But after I finish the show, this always happens. Like a bunch of kids just wants to come and play with my musical instrument. They don't care. They just start throwing things and they go really crazy. But kids are usually told by parents to not touch anything, right? So this is like a perfect moment for them. Like, and I can totally see, why they go crazy and things like that. But I want to make sure, as I work on more project, I can guide them better. Not just touching, but what is it? Why is it making sounds, right? And if you, again, look at MMRT, it took me so much discipline to be able to make that thing, like, craftsmanship, physics, music, acoustics, electromagnetism, computer science, psychoacoustics, right? So can I like translate those kind of like, learning components through that interface somehow? So while kids play with it, they're actually learning these things, right? How does magnet work, for example, right? That is to me very, very exciting and very challenging at the same time that I want to keep working on. So going forward with that kind of idea, I've been offering class for instrument building. This is one of the class I taught at the Colorado College, where this is the typical classroom, seeing students making their own musical instrument. And of course, it's partially digital system. So what is it? You see a bunch of computers alongside with a bunch of random everyday objects, basically, for example. And I'll show you some of the student work. Colin Turn, he was super into skiing, Colorado, right? It's high mountain. So everybody skis there. So, but he was so much into ski, he wanted to turn his ski gear into musical instrument, basically. So he attached a contact microphone and then have an audio processor so he could play it like a harp, basically, kind of idea. Kira came up with a visual score, or a graphic score is probably more the right terminology here, where it kind of describes her improvisational music style, kind of like evokes the water kind of quality. And then finally, John and the band created their kind of like a Guitar Hero based musical instrument, and cup based kind of like a melody generator type of thing. So instrument building is one direction I'm really pushing. At Berklee, I teach, I already mentioned this earlier, sound design course. What is it? And teach a bunch of a modular synthesizer class like this, where I get to show how to patch things, but at the same time, students are doing together. And students are learning things like how does each module components work, and then how the signal flows and so forth. And that's the language of electronic music. And there's no better way to teach this other than using analog synthesizer, in my opinion. So that's one thing. And we have I'm also teaching audio programming courses. Of course, some of the digital signal processing stuff, and also audio streaming. This is very more specific things, but maybe you've heard something like Ableton Live, Reactor, that's a synthesis programming language, Max MSP, I don't know, and also like C programmings and things like that. And also been teaching lots of multimedia performance. This is super recent work I've done with Berklee students. We set up like 5 projectors with a dancer and a bunch of computers, people trying to manipulate sound and visuals at the same time, trying to make the whole experience immersive and so forth. Yeah, so hopefully, these experiences I'm having right now teaching will lead towards, making better scoring instruments and, cater towards like a music wonders, basically. I'm going to end with 2 more kind of like a workshop kind of thing I'm doing alongside my teaching. One is the musification workshop. This is actually, I did it in 2015 in Sao Paulo. That was the beginning. At the Strange Music Festival, I gave a workshop which was about making a system to turn everyday objects into musical instruments. That was the idea. So I literally gave 3 things to every participant: amplifier, transducer, and battery. Solder yourself, and then attach them to some object that you're very interested in, turning it into musical instrument. That was kind of the idea. So this is the typical kind of like a workshop scene. I definitely teach how to solder, for example. But the cool thing is the generation gap here. You have like super small kids to super older person as well, like participating. This is like really something I really like to see a lot. Kid and parent come together and then building it together to figure out what's going on, kind of thing. So they, cup is a typical thing people wanted to turn into musical instrument, but right now it's connected to iPhone, so they can, kind of play around with it. That's another scene from the workshop. Here's a kid, playing piano through, and turning the cups into a speaker kind of thing so that he can play around with it. And there's a lady, first time soldering, trying to, and she had a problem seeing the actual thing because it was so tiny, but she will still be able to do it. And one thing I'm really proud of this workshop is I have 100% turnout rate. Everybody gets to build it. They don't leave until that happens. Yeah. Yeah. So if I have time, this kind of turns into a performance later on. Once they have their system, so they learn the technical things, but now let's think about, how do you make music with this, kind of thing. So this is what I did when I was here in 2015 doing the workshop. So you see a bunch of balloons again. Balloons are a pretty amazing source of sound, I would have to say. Yeah, so the final workshop I want to kind of talk about is something. Moduland is the actual project we came up with. But I gave a workshop called the Playful Machines That Make Music. And how many people participated in this? Like 16 people? Yeah. And this was in Berlin. But we came up with the idea of building a playground kit for learning electronic music specifically. And what is it? We kind of like brainstorm about, so how do we connect and collaborate with diverse people to make music? And again, talking about the mental barrier in music making, right? So don't get caught up in the technical stuff, but let's have fun doing music, right? And make electronic music more accessible. And Playground is like the perfect thing. Like when we go to Playground and trying to implement this, like kids naturally just come around. Hey, what are you doing to our playground? Kind of thing. Yeah, that was like pretty cute actually. Yeah, so I'm gonna skip this one. So how did Moduland work? Just like any other projects, we deploy sensors into the playground and then try to measure, for example, I think I have here, maybe each steps can be measured and then turned out into a musical activity. There were some sort of spinning things that we use the accelerometer to translate it into a music. There's some like bouncy thing that we could use. And of course the wheels and so much component in Playground that you could turn the motion into some sort of a electronic music component, like a low frequency oscillator or like envelopes and things like that, right? Yeah, so I'm gonna end with the concept video we came out with Moduland. Yeah, and look like this. We were short on kids on this video. Sorry about that, Art. Yeah. But through things like workshop and teaching, I would like to transmit the concept of musical wandering using tools available to us from low tech to high tech. I want to use this opportunity to connect people and have them discover their own musical language possible. For this to happen in the future, I would like to keep exploring more about what phenomena and new technology fascinates and invite people to spontaneously interact with music. And thank you very much for your time.
Thank you, Akito. You
Yes.
have time for questions?
Yes.
I love your images of musical instruments using Deep Dream.
Thank you.
But my question is about some of the software you were showing earlier. You produced these from 2012, and you started that series with Sound Derive.
Yes.
And considering you work at MIT, can I play around with this software myself? And is the source code available?
Very good question. So since I have graduated, I have not maintained the website. So it may not be running. Technically, it should be running. I can show you the URL.
That would be great.
And I am definitely working for the open source version right now. I've been expressed by many composers that they wanted to have this as their tool to engage in their local community and things like that. So I see a huge opportunity in, I don't want to keep this to myself. So eventually it should go up. Yeah.
And then related to that, to your project, or I don't think it's your project 305.
Yeah. So that was a collaboration work. They used our technology to do
Right.
their project. Yeah.
Because that was from 2017, I just checked it, and your earliest piece that was related to that was from 2012.
Yes.
So you've but something that is much older, but
Yes.
maybe no longer available?
I would say, so this project has been constantly evolving as I was, going through my PhD as well, right? By 2017, I said, that app that you can record sound, it actually also does video as well. That was a huge request over, because people are more comfortable or more familiar with, doing video recordings than sound recordings. So let's just do that.
Exactly.
And, you just have more content that way. So things like that evolved over time, right? By request and by demand and things like that. So older stuff is definitely, there, but newer stuff is much better.
I understand. And then my last question, because I don't want to steal everyone's thunder. How did you, or did you, were you involved in trying to convince people to contribute?
Mhm.
How did you manage?
Yeah,
to do
so
this?
I only talk about the online component, which was the major part for me, right? But again, the project itself was bigger than that. We actually went to the city a lot and then engaged local community by giving workshops, for example. We have another software something called the Hyperscore, which I didn't talk at all in this talk, but it's similar to the web score making web app, where you don't have to know any musical knowledge, and we typically try to engage young children in making music, symphony work especially, and so that's one type of thing. We definitely did lots of recording workshop. How do you use your phone to record nice sounding stuff? For example, that's another good context, and just meeting a lot of artists who live there, and they know way better than we do, right? Because they live there, and then being actively
Yeah, local
involved.
credibility.
Yeah,
Right.
and we often actually ask the artists to be part of the final performance as well with the symphony orchestra. Yeah, which is adds another additional layer to it. Yeah, so yeah, I only talked about the online component, but
Sure.
it's much bigger. Yeah, in that sense.
Thanks.
In the Sleep No More experience,
Yes.
with the about the mask,
Mhm.
what you do about with the data you collect?
What do we do?
Yeah.
Yes. So one thing we wanted to make sure is where that person is. That was a very big part because we can't. Well, we could technically have someone follow all the time, but that's labor intensive. So and each trial we did, I said we did it in a week span, and every day 5 pairs went into the performance, right? And it matters a lot where they are because based on that we can trigger different stories, basically, right? So indoor location tracking, determining, oh, this person is right now in the room of which, for example, then we can trigger specific story related to that, and then communicate that, hey, this person is right now in the which room to the online person, so they can have the appropriate context and conversation based on that kind of idea. So that's one example of the use of the sensor, right? I would say the bone conduction headset was used more than anything else to communicate to the on-site person where you should be going, right? So that's kind of like another navigation stuff we've done a lot, yeah, in that context. Yeah, just so that the performance space didn't have any internet to begin with. We had to actually pull the cable, the entire building to be able to do this. It took about a month to set up, and then only a week of deployment, and then we had to break down everything after that.
5 people a day, so only 35 people, 70 people enjoyed the
Something like that. Yeah, it was very limited trial experience. Yeah.
And the biosensors.
Yeah, biosensor was a little bit, we couldn't actually use effectively, I would say. First of all, the reason why we wanted to have a biometric sensor is because audience members cannot talk. So there's no way for us to find out what kind of state that person is in. And biometric was, one of the ways to find out what that person is going through right now. Yeah, but I don't think we ended up using the information. I think the only moment we really used was the heart rate, the BPM, and translate that into the interface of the online participants, or color of the displays, for example, based on that. So if the person has a higher level of like heart rate, the display becomes a little more red, for example, indicating some sort of urgency or something like that. Yeah.
But you can link the data about a sort of spectators
Right.
about a scene is going well or not.
Yeah. It's definitely yes, I would say. Yeah, it's hard to say. Everybody like behaves differently. Yeah, that's a given thing. I would have to say. Yeah, I'm not sure if that answers your question. Yeah.
Okay.
Yes.
I feel like projects have a lot to do with collaborations. Do you take any source of open source collaborations?
What sort of collaboration?
Open source.
Open source collaboration. We're so much of the work is not open source just because what is it? It's not ready yet. I'm for open source, but when I open source it needs to be useful, right? Like it actually works. So like that takes a lot of effort. And while I was doing research, that was not the focus. Publishing it as an open source, but actually implementing the whole thing and then verifying that it actually works. That was more important. So open source stuff is, now a thing for me. Like, as I get more time, I will try to deploy it out in the world. Yeah.
As a creator of new musical instruments and interface, what does it, or how do you deal with existing instruments? Like, or is it for you important to analyze how a guitar works or to get some information from that?
Yeah, I would say actually that's a really good question because most of the, if you look at, for example, NuSom community, focus is exactly that, like taking an existing musical instrument and augmenting them, right, with a new capability. Actually, the Opera of the Future group was originally called the Hyper Instruments group, and that was the whole thing, like taking the cello and measuring the performative quality. So like, what is it? We made a glove, for example, that measures how it's blowing, right? Like how tight the grip is, what's the relationship of the bow to the body of the cello, for example. Those information are very, very important, especially if you want to make new musical instrument cater for expert musicians. In my case, I'm not interested in expert musicians so much. I am, but but I think there's more. For me, what excites me about these new technologies is the possibility to open up music for everyone, and that I think requires new type of musical interface. Because if you look at like traditional acoustic music, musical instruments, you need to practice them, like to get really good at it, right? And it could be not fun at all for people who are just starting, right? It took me, at least like 2 years or something like that to really start to get good at guitar, for example, right? And you need a serious commitment to be able to do that kind of thing, which is not a bad thing at all. It's just a different way of, playing music. Yeah. So I think with new technology, there's going to be a new paradigm of like music making. That's what I believe in. Yeah. Hopefully that answers your question.
Following his question, just wondering about because if I got it right, you are more into the interface part of the development. But how do you look into the musical content? Like if you have the form and the content, you are more in the form.
Right. It's a very valid question. I mean, I'm talking about more from the research context. One obvious way to measure it is by doing performances, right? And then seeing the reaction of the audience members. Did they like it or not? And then what kind of audience member actually liked that, right? Very subjective, but still useful feedback. You could do more systematic user studies. That's more pervasive in a human-computer interaction kind of a community, for example, right? Give this musical instrument to a person who doesn't know anything about music, and then have it use it for like a week or something like that, and then get all the data out of how did this person play that musical instrument, and you could do some quantitative analysis based on that, for example. That could be a very useful thing to do. So it depends, I would say, how far you want to push to evaluate your new musical interface. Yeah.
But this new interface makes a specific kind of sound and plays a specific kind of music. Like
Yeah.
many of your especially the first examples, they have some classical concert music
Right.
on the background. So,
Right.
It's
Yeah,
different if you have an abstract sound coming from the interface.
Right.
Except of Mozart or Beethoven.
Right. I see where you're going with this also, and so one of the concept I'm trying to get at is again, when you talk about HCI community type of thing, people talk about mapping a lot.
Mhm.
You have a knob. How do you connect that knob to a sound, right? That's a mapping system, right? So I want to skip that part as much as possible. And I think making the musical instrument as physical as possible is the way to get away with that problem. So that's the reason why I'm doing MMRT, for example, turning everyday things into musical instrument itself. So mapping is not systematically done by the instrument, but the person does it, kind of thing. That is something I think, way to develop your own musical language that way, right? So this object worked well with this kind of mode, for, percussion kind of thing, or melody kind of thing. I don't know. That's something I want to leave it up to the person who's going to be using for example. But, it kind of necessitates, if you go back to the City Symphony project, if everything is online or digital domain, the mapping needs to exist somehow. Yeah, so that's more of a tricky one. So the way for us to get away with that problem is to ask the community to contribute the original sounds, right? So yeah, there are some tricks to get around with that kind of making it not too strict, I guess, in a way. Yeah. Hopefully that answers your question.
Yes.
Yeah.
About the interfaces created by AI,
Mhm.
do you to build these interfaces? We are interested in this.
Right.
And if you are, how do you think about the ergonomic?
It's a very good, valid question, and this is the next step we are working on this summer. First of all, we need to choose which one to build, and then assigning again comes down to that problem, right? What is this knob is going to do? And I don't know. There were some images that knobs kind of like align nicely, kind of thing, right? Those are kind of like the interface I'm kind of interested in picking, because maybe I can assign like specific like step kind of thing that associates with each other by tweaking those knobs or something like that. I would need to come up with some sort of a metaphor for maybe that metaphor is going to come from the original paintings done by the artist. What was the intention that was given originally, and then if I translate it into the musical context, what does that mean, right?
Maybe it should be a device to create paintings.
Yeah. That could, so like a video synthesizer, maybe.
Yeah.
Yeah. That's a totally possibility. Yeah. So it's unknown, I would say, for now, and I would need to put more thoughts on it. But any thoughts from you would be appreciated too. Yeah.
And just one more question.
Mhm.
We have had some experience with how we call it, community open systems.
Right.
Like Ariane, who was a former student, she made a system that would collect input from smartphones,
Mhm.
like in a chat environment, and what people would type on their phone would sound in some particular way. And one important subject that she didn't figured out when she started the project was how to control the content.
Content.
Yes.
Yep.
They have something, because it showed many works that were based on community
Right.
input. So,
Yes. So that partially, becomes a huge problem, especially when you're doing real-time stuff, right? Like during performances, people can type in anything. That means you need some sort of filter, right? So I would give you an example. For example, for the Sleep No More, where we had the direct communication between remote person and the on-site person. there was the control room, right? We were constantly monitoring what kind of conversation that was going on between them. If anything inappropriate that breaks the performance, no, we just like reject it. Yeah.
Okay.
So there were human filter in between, basically. Yeah, but that is actually
the filter would be a real person.
Yeah, and it works very well, actually. Yeah, yeah. So that is something I would recommend you doing if you have the labor to do that. But sometimes you might not. And unfortunately, the technology for filtering these things out is not perfect yet, right? So I would say another way of thinking about this is to restrict the interface. Focus on the abstract communication rather than explicit communication. That might solve lots of problems based on that. Yeah.
More questions? Oh, I'd like to thank you again, Akito.
Yeah.
And
Thank you very much, everyone.